Yeah, that should have happened earlier. James is going to talk about the new training centre in Cubesats, UAVs and their applications. Training centre of which I'm Deputy Director, but I've only just right now. He's born in Dublin, has a bachelor's in mathematics, 2 master's degrees in space science and physics. He's experienced in working small satellites with Defence Space Robotics Laboratory, Ames Research Centre at NASA, and he's now at Sydney Uni. Thanks, James.
Thanks very much. Can everyone hear me? Hello everyone. My name is James, and I'm here to talk about updates on INSPIRE-2, as well as the new training centre and some projects we're going to be doing this year. So, it's already discussed briefly there as well in June, but INSPIRE-2 was a collaboration between 3 universities, University of Sydney, University of New South Wales and Australian National University. And it was a collaboration for the Global Small Satellite Research Programme, QB50, that was done by the Von Karman Institute in Belgium. You see the team pictured here, you probably recognise some of the faces. Probably a few of us remember already. And then here are the 3 satellites that were going in for thermal vacuum testing for the ANU's ASCC facility. And from left to right, that's ECO, and then INSPIRE-2, and then USyd. And the project was aimed for a period of 1 to 2 years to monitor the thermosphere for space weather and for long-term trends. And as a requirement for the QB50 program, we were required to bring a multi-needle linear probe onto the spacecraft, as well as we had some payloads of our own. So the satellite started at the end of September, to be precise. Went on for about 10 months before I handed over. So as I mentioned, the QB50 required that we had the multi-needle linear probe, but also we had a non-photonic spectrocraft that was done by the photonics group at the University of Sydney, and this was devised to have no moving parts, 7 optical fibre cables connected to a photonic grating with also a lensing system on board that was able to take images of the dispersed spectra. There's a radiation counter, which was a standard Geiger tube system, very low mass, small, and it was low power. This was counting high energy photons, X-rays and gamma rays, and it was developed by the fusion plasma physics group at the University of Sydney. On that radiation counter board there was also a micro dosimeter, which was a standard solid-state scintillator, and that was developed by the space engineering group at University of Sydney as well, and that was also low in mass and low in volume and power consumption. There was also the Kia GPS instrument, which was developed by UNSW, and then there's also support from ANU as well. So, as June mentioned in the last presentation, there was difficulties in the beginning. We couldn't get any contact with the satellite, and then after reaching out to the radio astronomy or the radio operations community, they were able to get some contact and were able to overcome the battery issues. And finally, after a long time, we were able to get some data on the health of the spacecraft, some beacon data. And initially everything was fine, and there's no over-concerning irregularities. And all the temperatures in the spacecraft battery and solar cells were working fine with the expected day and night transitions. And there was lots of media attention as well due to the fact that it was found after a long time. There was downlink issues as well, which were off hours. But this was over. But we were getting health data. But before we got any payload data, that wasn't the end of the issues, and the next one was more fatal, I suppose. On day 37, that was the last time the satellite went silent for about a month and a half, and then afterwards, when it came back, it showed some corruption in the satellite, and the solid system was corrupted, and then a few of the sensors, including the temperature sensors on board, weren't working, which was kind of indicating some damage to the boards. So the question then of why did this happen, or why did this happen? So we still don't know, so this is highly speculative, but recently we got some data that there's some space weather events a few days before the satellite went silent. So you can see in the 10 MeV and 40 MeV graph down the bottom. A few days before INSPIRE lost its beacon, there was a large surge in solar energetic particles, maybe caused by CME. So that was one thinking that we had for why it might have caused the satellites to get damaged. And then, so we don't have any payload data, unfortunately, because we do have those downlink issues, and some of the spacecraft looks like it's damaged. But we still are getting health data for the beacon, so we're kind of hoping to get some information that we can put in use for research. So these are two graphs that we were able to do recently, which show the altitude of the system. And there are 2 points where here we can see that so the altitude of the red line, and there's 2 points when the altitude is decreasing, the rate increased. And then when you graph this against the flux that was coming from energetic particles, it was actually coinciding with that. So hopefully in the future we can get some more information using the health beacon data from INSPIRE-2. Now to move on to the training center, which as Andrew said, I'm the engineer for. And it was proposed 8th December 2016. There was a grant awarded in June 2017. 4.6 million from ARC and 1.2 million from partners. There's 12 partners, 2 Australian universities, 4 Australian companies, and 4 government units, and 2 US universities. Hoping to have 5 postdoctoral students and PhD students, and hoping to have 1 Cubesat campaign per year and 1 UAV campaign per year. And the institution agreements with the start of the centre in December 2017. Goals of the centre are to train the next generation of workers in cutting-edge advanced manufacturing, entrepreneurship, and commercial space, develop new instruments and technology, and develop a world-class Australian industry in Cubesats, UAVs, and related products. And so there's 3 themes: systems, instruments, and products of the centre, with 12 projects we're hoping to do over the next few years. So the plasma thrusters that we hope to use in one of our satellites in the next few years. High-speed communications, which we'll be incorporating into our next satellite, which will be talked about tomorrow by Parks Michaels as well for AirWave. We plug-and-play components, which are very common in CubeSats. There'll be compact imagers, photonic spectrometers, hyperspectral imagers, which will be integrated into UAVs and satellites. Calibration, validation, which actual tether. And the products will be remote sensing for coastal, marine, land, agriculture, forestry, and minerals. And then GPS, sea state reflectometry, radio occultation, and space weather control systems. So just to talk briefly then about the next satellite that we're designing now for the centre, which will be the satellite's first centre. So it's a 3D satellite that's based on the INSPIRE-2 design with some changes to try and overcome the problems we had before. So the blank faces, so it's a 3D satellite. To increase size from the 2 we have for INSPIRE-2, and 4 deployable antennas, and then there's 2 deployable solar panels. And the blank faces will be discussed, or they're left, the bottom one here is left for air-to-wave payload, which is a company that's going to aim to get gigabit per second communications. So here's talk a bit more about Quava, yeah. So it's called Quava-1 because that's the acronym for the centre. Cubesats, UAVs, and applications, and it's the first satellite, so it's Quava-1. Mission is Earth observation, GPS, space environment, and technology demonstration. And the launch hasn't been booked yet, but it's getting very close to doing so. And we're hoping by late 2018 or early 2019 we'll have a launch. And the integration will be carried out at the University of Sydney. And we're testing and we're outsourced testing after that. So the big changes that we have for Quava-1 from INSPIRE-2 is innovative solutions in space. It's the main supplier of the components now. Be very careful with the acronym for that one. But so we're using ISIS components now, and whereas the last one was more ground space. One of the main reasons for this was that we're trying to overcome the uplink downlink issue that Gino talked about. So we're going for a full duplex system, which ISIS has. It's also 2U to 3U, as I mentioned, and the airwave payload is the bottom 0.8U, which we're hoping to be a world record gigabit per second comms. And then the other payloads are similar to INSPIRE-2, the key GPS receiver from UNSW, and then a radiation counter and a similar, a nanospec from the University of Sydney. Also, on the last satellite, similar to what June said, we had the ISIS magnet torque aboard as well. So we're hoping to have, so we wanted a better ADCS system for this satellite. So we went for the Maryland Aerospace System, the MAI 400, which Monique talked about earlier for booking it. So we're also going to use that, but we're using a one reaction wheel system. And we're hoping this will be able to give us the pointing actually we need for some of our payloads. And then finally, I'll just talk a little bit about, so over the coming months we just started with the UAV project that will be provided by INSPIRE-2, a big drone, and we're hoping to demonstrate some of the payloads for that, as well as some of the payloads that we'll be taking for our satellite mission. Yeah, okay, this is the last, or second last one. So the comms package from AirWave, which is the gigabits per second communications that I talked about briefly before, that'll be on 501, or not that, it won't be the same one, but the same company. There'll be a GPS instrument provided by UNSW, an imaging spectrograph from USyd, and then there'll be multiple hyperspectral cameras from University of Sydney, Arbor Carbon, DSCG, and High Vista. And so we're hoping to demonstrate a lot of these technologies that we can use for our products that we want to do for our goals for the centre. And then just finally, as a conclusion, but for INSPIRE-2, the training centre, and Koala, and the UAV. So INSPIRE-2 and the other Australian Cubesats to demonstrate the existence of Australian space capability and breaking the economic barrier of Australian entering the space community. INSPIRE-2 is still alive. We didn't get any payload data, unfortunately, but we did get some health beacon data, and it was a big step for the Cubesat, for our Cubesats. And then the training centre has started, and we're already producing our first projects now. So we aim to launch one satellite per year, and the next one's going to be Cubesat1, which we hope to do by the end of the year. And then we want to do a UAV project, and by doing these, hopefully train the next generation of space engineers. And we are open for collaboration on space science, technology, and commercialization, so please feel free to talk. And so hopefully you'll look at Cubesat1 in the next year or so. So hopefully it goes well. So thanks.